I want to show you how the Gibbs energy and the equilibrium constant are actually related, and we can do this mathematically. It's called a derivation. We have an equation that says that we can adjust the Gibbs energy away from the one at standard conditions, which is the G naught. I have to add in R, our gas constant, times the temperature, times the logarithm of the pressure. Here I'm dividing by 1 bar. I can divide by 1 atmosphere. The whole point is to actually make it unitless, because when you take the logarithm of a number, it needs to be unitless. And so at equilibrium, the change in the Gibbs energy is actually equal to 0. That's what equilibrium means. And so 0 is equal to G naught plus RT log P divided by 1 bar. And so I'm going to move the RT over to the other side. Well, you'll see what I'm going to do. I'm going to have G is equal to RT, negative RT, times the log of the pressure divided by 1 bar. And now what I really want to do is use this for a reaction, because that's when we actually have an equilibrium. And in order to do this, I need the sum of the products, and I have to subtract off the sum of the reactants. And so I have the delta G for the reaction under standard conditions, which is the delta G for the product and the delta G naught of another product. And I'm going to subtract off the delta G naught of reactants and the delta G naught of a reactant. And so here, let me actually use a sample equation. I'll have A plus B going to C plus D. And because it's in equilibrium, it actually goes in both directions. So I can rewrite this as the Gibbs energy. In this case, it's actually of formation for C plus the Gibbs energy of formation for D minus the Gibbs energy of formation for A minus the Gibbs energy of formation of B. And that's going to be equal to negative R times T times the logarithm of the pressure of C plus the logarithm of the pressure for D minus the logarithm of the pressure for A minus the logarithm of the pressure for B. And now I can simplify all of this. This actually is the Gibbs energy change for the reaction under standard conditions. And this is minus RT log, oh, wait a minute. This is the pressure of A times the pressure of B. And I'm going to subtract the logarithm, C and D. And this is the logarithm of the pressure of A times the pressure of B. But subtracting this means that this is the logarithm of the pressure of C times the pressure of D divided by the pressure of A times the pressure of B. So this is times the logarithm of, oh, wait a second, this is our equilibrium constant in terms of pressure. And so something that we actually discovered graphically, we can also do mathematically.